So today we're going to talk about even and odd functions. So in order to test for whether a function is even, odd, or neither, the test is always to look at each x that you have in the function and replace each of those x's with a negative x. And we're going to talk about why when we're done, why that tells you whether the function is even, odd, or neither. So what we're going to do is every time we see an x, we're just going to replace that with a negative x and use some algebra to simplify that down. So I know that I'm going to follow order of operations here. So parentheses come first and then exponents. So I'm going to simplify my negative x to the fourth power. Now, when I take a negative number and I raise it to an even power, which is going to happen in both cases here, that's going to turn my number to be positive. So negative x to the fourth simplifies to x to the fourth. And here negative x to the second power, that's the same as saying negative x times negative x. So that's also just positive x squared. So what I notice is when I try to evaluate what f of negative x is, I get back the original function. So when that happens, when you replace every x with a negative x and you obtain the original function, what this means is that the function f of x is an even function. And I'll show you what that means by using a sketch. If you look at the sketch of 2x to the fourth plus x squared, it looks kind of like a parabola. It's not quite a parabola if you zoom all the way in. And there are 2 points on here that I know for sure on there. So negative 1 comma 4 and positive 1 comma 4. So there's a couple things you might notice about this sketch. This sketch is, and this graph is symmetric over the y-axis. And when you're symmetric over the y-axis, what that means is for every x comma y, every coordinate that exists on this function is going to have a corresponding point to it where the x coordinate maps to its negative or its opposite counterpoint, and the y value stays the same, as is the case in negative 1 comma 4 and positive 1 comma 4. So if you notice, if I consider the point that I have 1 comma 4, that gives me a corresponding point that's also on the graph, which is negative 1 comma 4. So the test for figuring out whether something is even, odd, or neither is to replace an x. If I need to test algebraically, I'm going to replace every x with a negative x. And if I obtain back the original function, that means that f of x is even. Now, graphically, I'm looking for symmetry over the y-axis. And when I see symmetry over the y-axis, I know that that means that the function is even. And numerically, I'm looking for this specific point mapping. So we're going to do another example of something that's going to not be even. So let's say I have the function f of x is equal to negative x cubed plus x. I'm going to do the same test here. I'm going to insert a negative x for every x value that I see. And I'm going to simplify that down. So I'll get negative, if I take a negative x and raise it to a third power, that's the same as negative x cubed. Plus a negative x is minus x. So this turns into positive x cubed minus x. So what I want to think to myself is here, how does this relate to the original function? So just by observing, I notice that this looks similar to the original function, but it's off by a negative. So I'm going to go ahead and take a negative out, pull out a negative as a GCF, and I will see that if I do that, I get the negative of the original function. When that happens, when f of negative x is equal to the opposite of the original functions, here is where we say that f of x is odd. And so we're going to take a look at that graph for this function as well to see if we notice any symmetry here. So a rough sketch of that graph will produce a function that looks just a bit like this. And this does have a type of symmetry as well. This is symmetric over the origin. And the reason I see that is because when something is symmetric over the origin, that means that half of the function reflects twice over the x-axis and then again over the y-axis. And anytime that we have that type of symmetry, we see a specific type of point mapping. So I know that on this graph is the point negative 2, 6. And corresponding to that point, I also know that the point positive 2, comma, negative 6 is also on that graph. And I can check that by looking at a table of values. So after I see this symmetry, I also notice that the point xy maps to negative x, negative y. So we can check that. That means if I consider the point negative 2, 6, which is on the graph, I will also find a corresponding point where both of the signs of those coordinates turn the opposite sign. So negative 2 becomes positive 2 and positive 6 becomes negative 6. So again, just like before, algebraically, I can check for even, odd, and neither by replacing every x in the equation with the negative x. Graphically, I can check for symmetry. And numerically, I can check for this specific point mapping. I hope that's helpful.